Okay, so let's start. So we were talking about aggregation the last time around. This wasn't something that was covered in the midterm, but let me try to give you a quick recap and then we'll go from there. Okay, so the first thing with an aggregation is that you can use an aggregation function and apply it to an existing attribute and list these aggregates as part of the select. So in this case, I've listed average price. In addition, there is this construct which we introduced, which is group by. So you are basically saying that you are, so prior to performing the aggregation, you collapse the set of tuples into groups corresponding to various values of this attribute, which is beer. Okay, so that's how you think about this this query. And let's keep going and see how other examples look like. So this is a query where I want to find from cells, and frequent cells contains bar, beer, and price, and frequent contains drinker and bar. I want to find for each drinker the average price of bud at the bars that they frequent. Okay, so immediately when you see for each, that's an indication that this is something that you might want to potentially group by. Okay, so let's start by the basics, right? So you start with frequents and cells. You want to do a cross product of those two. In fact, it's not just a cross product, it's a natural join. So you're joining those two on the bar attribute. And in addition, you want to focus on those tuples, those join tuples where beer is equal to bud. Okay, so this part of the query is computing combinations of frequents and cells corresponding to bud tuples at various bars, drinkers, and prices. Okay, so that's how much I've gotten so far. And then I am grouping these tuples by various drinkers. So I have you can think of, you have a bunch of tuples, and then I have sort of one group corresponding to drinker 1, one group corresponding to drinker 2, and so on. And then I want to apply some form of aggregation. In this case, I am applying average of price. So you have, let's say, the price attribute here. I want to take all of those values for each drinker and then display that as part of my select clause. Okay, so this is how I think about this this query. So there is a natural restriction for what you can use within a select clause. Something that you want to use within a select clause either has to be something that you're grouping by or something that you're aggregating. And the reason for that is that you are essentially starting off with a relation and then you are grouping these tuples into groups based on the group by. So for each group, so after that point, once you've started grouping, after that point you have a bunch of groups. For each group, you have to return a unique value. Okay, so if you've grouped by an attribute, that attribute obviously has a unique value. If you're aggregating by another attribute, that obviously has a unique value. But any other attribute cannot be used in the select clause. It either has to be aggregated or it has to be grouped by. Okay, so it does not make sense to neither to have an attribute that's neither grouped nor aggregated, because you're dealing with a group of tuples and you have to collapse them down if you want to display it. Okay, so that was the restriction on what you can have in the select clause. Now let's try to sort of talk about one common misconception some students have. So let's say I want to find the bars that sell bud at the least price. Okay, and this misconception comes from a misunderstanding of what the grouping and aggregation is meant to do. Okay, so let's say I'm trying to find the bars that sell bud at the least price, and let's say I have come up with this query, which is select bar min price from cells where beer is equal to bud and group by bar. So can you tell me why this does not make sense for the query? The query is trying to find the bars that sell bud at the least price. So why does this query not make sense? So it makes sense from a syntactic standpoint. Why does it not make sense from a semantic standpoint, from a meaning standpoint? Why does it not satisfy my goal? I want to try to find the bars that are selling bud at the least possible price. Yep?
Because every bar will sell the bud at the same price?
Because every bar will sell bud at the same price. Let's say they don't. Let's say they don't.
I mean, every bar will sell the bud. They will have only one price.
Every bar will sell bud at they will have a single price for bud.
Yeah.
And so what does that give us? Yes?
So min price will only return that one price for every bar because there's a group by bar.
Correct. So I think you were also trying to get at the same answer. So basically, you're grouping by the bar, and because you're grouping by the bar, for every bar you're going to take all of the bud tuples. Maybe there's one tuple, maybe there are multiple tuples. You're going to collapse that down. And so for every bar, you're going to return the minimum price that that bar charges for bud. And like you said, if there's only one tuple corresponding to bud for a given bar, that tuple will be returned. Okay? So that's not going to be useful, right? That doesn't still answer the question of which bar sells bud at the least possible price. So applying min in this way does not work for my query. So any guesses on how I might want to do this? Any sort of high-level suggestions based on the other constructs that we've seen so far? Yes?
We can first use a subquery to find the minimum price for bar, and then we can select bar which has that price for bar.
Perfect. So his suggestion was, why don't you use a subquery to find the minimum possible price that bud is sold, and then you use an overall query which tries to check whether the price that they are selling bud at is equal to this. Okay, so let's try to work through that. So it would be select bar comma price from cells where, and what would I have here? So this would be the subquery. What would I what would I want to do? Maybe price equals, maybe actually let me start with beer is equal to bud, and price equals what do we think? Do we want a equals? Do we want or something else? There are actually multiple ways of doing this. Any suggestions? There's some ways that don't even involve min. Any thoughts? Okay, so so one way to do this would be to select, if I use an equals, I can do a select min price from cells where beer equals bud, right? So this is the minimum possible price that I can have for bud, right? And if I'm setting price to be equal to that, then that gives me all of the bars that are selling bud at the least possible price. Instead of using min price, I can do some of the other constructs that we talked about before the midterm, including all So you can go and think about how you would do it without using min, but using all, or some other such, maybe, I think all would probably be the only one that I can think of right now. But you can try to replace this guy with some other operator and all, and see if you can do achieve the similar result. Okay, so that's something for you to think about offline. You should be able to do it given the tools that we covered prior to the midterm. Any questions about this? Yes?
Can you explain again why the first query won't work?
Okay, so the reason why the first query won't work is, let's say you have bar, beer, price, and let's say you have, I don't know, Joe's bar with Bud and 10, Mo's bar with Bud and 12, and Mo also, let's say, serves, I don't know, generic IPA at 5, Mo sells blah at, or whatever. Let's not do another Mo. Let's do Joe again. Joe sells IPA at 6. Okay? So now, if I am running this query, what is going to happen is I'm going to start from cells. Okay, so this is cells. So start reading it from this part. Okay, so the from and the where clause. And from the from cells, I'm going to eliminate all the tuples that don't correspond to Bud. Okay, so that's the first thing I'm going to do. Make sense? So I'm going to eliminate this and this. Okay, next I'm going to group by bar. Okay, so there's one group corresponding to Joe, one group corresponding to Mo. Yes? Okay. So then after that I'm going to go back to the select clause. Select clause is going to say select bar and min price across all of the tuples corresponding to each bar. So you have one group corresponding to Joe, there's only one tuple there. One group corresponding to Mo, there's only one tuple there. So the minimum is going to be just 10 and 12 respectively. So the answer that you're going to get is Joe with 10 and Mo with 12. This is not going to answer my query, because the query, what I wanted the query to return is not both of these tuples. I only wanted it to return Joe 10. Right? Make sense? Okay. Okay, so you can try out how to do this without the min construct and instead using the all construct later on. Okay? So let's move on. So this was the query that I constructed. So we're good on that front. So sometimes we might want to follow, we might want to sub-select some groups that we care about and discard other groups. The having clause allows you to apply a condition following the grouping attribute or following the grouping clause. Okay? So this having clause allows you to apply a condition to each group, and groups that are not satisfying the condition are eliminated. So once again, the way to think about this expression is, let's say this is the set of tuples that I'm operating on. This is the set of tuples that I've gotten after taking the cross product of all of the relations in the from clause. Okay, so this is the result of the from. Okay. After that, I go ahead and eliminate some tuples, those tuples that don't satisfy the select clause. Okay, so I get a smaller set of tuples. Let me erase this. So I get a smaller set of tuples. This is after the select clause. Okay. After that, I apply the group by. Okay, so I might collapse these three tuples into one group, these three tuples into another group, these three tuples into a third group. Okay, so I now have a smaller set of tuples corresponding to one corresponding to each group. So this is after the group by. After that, I can do a having to eliminate some tuples from the results of the group by. So I end up with an even smaller number of tuples. Okay, so having is similar to select in that it is throwing away things that don't satisfy, but it's applied after the group by. Okay, so it's applied at the level of the aggregation rather than the individual tuples. Okay, so it's after you've aggregated the tuples down into groups that you're applying the having clause, unlike the select clause which is directly operating on the raw data. Okay, so let's walk through some examples. Based on my explanation so far, what do you think this query evaluates to? So I have select beer and average price from cells where group by beer having count of bar is greater than or equal to 3. Any guesses? So once again, I'm operating on cells. Cells has bar, beer, price. Any guesses? Yep.
Is it the average price of beers sold at least 3 bars?
Close, but not quite. Wait, hang on. Say that again. I might have gotten you wrong.
The average price of beers that are sold at least 3 bars?
Average price of beers that are sold at least 3 bars. You're right. Sorry, I misheard you the first time around. So you're right. So what he said was the average price of beers that are sold at least 3 bars. And why is that? So once again, the way to read this is you start from the from clause. You've taken the bunch of tuples that correspond to cells. You've grouped them by the beer. Okay, so you have one group corresponding to each beer. This having clause is checking if the number of bars that this beer is sold at is greater than or equal to 3. Okay, so precisely what you said. And then after that, once I've thrown away all of the groups corresponding to those beers that are not sold at least 3 bars, I go ahead and return the average price for each of those beers. Okay, so that's the meaning of this query. Any questions about this? Okay. So the requirements for the having clause are similar to the requirements for the select clause following a grouping. Okay, so basically these tuples may refer to any relation or tuple variable in the from clause, and within that they may refer to attributes of those relations as long as those attributes make sense within a group. Okay, so as long as those attributes have been collapsed, have been aggregated within a group, so either they are a grouping attribute or they are something that's being aggregated. So we saw here that we used count, right? Count is perfectly fine to use because, count of bar is perfectly fine to use because you've taken all the bars, collapsed it down into one number. Okay, but if I instead had some count, instead of count I had bar is equal to something, this won't work because you've collapsed these tuples down to give one tuple for each group, right? You want one tuple for each group. This does not guarantee that. You could have multiple bars corresponding to each beer, right? And because of that, you can't use such a clause in your having part of your SQL statement. Okay, so you can't use this predicate bar is equal to Joe as part of your having clause. Similarly, you can't say and price is equal to or price is greater than 3 or something. You can't say that because once again you've not aggregated on price yet. Okay, if you say instead average of price is greater than 3, that's totally fine. But you can't say price is greater than 3 because you've not aggregated on that. That makes sense? Okay. Cool. So this is the most general form of SQL that we've seen so far. And I'm going to walk through the formal semantics and restrictions once again. So the select clause can contain, so once again, you have a bunch of group by attributes A1 through AK. So the select clause can contain attributes A1 through AK and or any aggregates, but no other attributes. Okay, so you can use attributes if they've been aggregated or they are listed in the group by clause. So they've been grouped by. C1, which is the where clause, is any condition on the attributes in R1 and R1 to Rn. So there's no restriction on C1. C1 is applied before grouping takes place. C2 is any condition on the aggregate expressions or the grouping attributes. So just like the select clause, it has to be applied on the aggregate expression, so something that's being aggregated or something that's being grouped by. Okay, it can't be something that's not in one of these two. Okay, and then how do you read this? Well, this is something that we've already described. So you start with the from and where, you do a cross product of R1 through Rn, you apply the where clause, you eliminate the tuples that don't match, and then you group by A1 through An. So you have one group corresponding to each attribute or each combination of attribute values for A1 through An, A1 through AK. Then you compute all of the aggregates in C2 and keep only the groups that satisfy C2. Okay, so you look at all of the aggregates that are required in C2, you compute those aggregates, you compute the condition and throw away some of these groups. Okay, then finally you compute the aggregates that are required for S for the remaining groups, so these two are remaining, and then you return that as your result. Any questions about this? Yes?
Do we have to have the same number of aggregates in S as we do group by attributes?
No. So there are three sets of attributes that are showing up. Okay, so there's one showing up in the group by, so that's one set. The other set is showing up in the having, and the third set of attributes that are showing up are in the select clause. Right. So there is no restriction as to what the having clause should contain, as long as it's either a vanilla condition on one of the attributes in the group by, or it's a condition on some attribute that is being aggregated. If it can be any attribute as long as it's aggregated. Similarly, for the select clause, it can be any of the grouping attributes potentially, and any of the other attributes if you want to aggregate them. So any of the attributes are allowed as long as you want to aggregate them, or you can show some of the group by ones. Okay, so like we saw in that example earlier, we did a count of bar in the having, but we displayed the average price in the select. That's totally fine. So what did you have in mind? Does that answer your question?
I think so, yeah.
Okay, okay. Any other questions about this? Okay. So that's it with aggregation. Let me move on to SQL modification statements. So don't save. Okay. So far we've been talking about how to query the data in a database, but how do you actually go ahead and modify the data in a database? This is also as important as understanding what's in the database and querying it. So modification command is different from a querying command because it does not return a result, it just changes the data in the database. And there are three types of modifications. The first is you want to insert a tuple or a set of tuples, delete a tuple or a set of tuples, and update the value of an existing tuple or set of tuples. So the insertion statement is pretty straightforward. You say insert into, and then you say give the relation name, and then you list, you say values, which is a special keyword, and then you have a tuple which is corresponding to a list of values. Okay. So here's an example. So let's say I have likes, which is defined by person and beer, and I want to add a tuple corresponding to Sally. and Bud. I can do that by saying insert into likes, values, in parentheses, Sally and Bud. Okay, so this is one tuple that gets inserted into the likes relation. Okay, so let's talk about generalizations of this. So this was the simplest case. So one simple modification of this statement is that here we've not specified which attribute Sally belongs to and which attribute Bud belongs to. If we don't remember the order in which we listed the attributes when we defined the relation, then this could lead to problems. If by mistake I listed Bud and Sally when I had defined the relation to be likes, person, beer, then it's going to lead to something that I don't want, right? So the Bud would be added as a person and Sally would be added as a beer, so you'd have a tuple corresponding to Bud and Sally in the opposite place of what you intended. Okay, so in such cases where you don't remember the order of the attributes listed in your relation, you can explicitly go ahead and say which attributes are in which position. So you can say, look, for the purpose of this insert statement, I'm going to say this is person and this is beer. Okay? So, and even if the relation was declared as likes beer, comma person, internally the database will look at this query and then will map the right attribute to the right location. So it'll move Sally to this position and then Bud to this position because that was how it was declared in the database. Okay? Is that clear? Okay. So like I said, you can be more explicit. You can say, you can list out the attributes here, and all that you need to ensure is that the values correspond to the attributes in the order that you've listed in the into relation part. The other thing that you can do, another generalization, is you don't need to stick to one tuple at a time. You can list multiple tuples. And the way to do that would be to just replace a semicolon here by a comma, list another tuple, comma, blah, 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 and then you have a semicolon at the end. Okay, so you can add another tuple, I don't know, IPA, John, and so on. Okay, and that's totally fine. You're just listing multiple tuples. All of these would get inserted into this relation likes. Right? Okay, so so I gave you one reason to specify attributes in the insert statement, which is that you may not remember the order in which you had listed the attributes in the relation. So that's a good reason for us to explicitly list the attributes in the insert statement. But there's another good reason as well, and the other good reason is that we don't have values for all attributes. So maybe there are 10 different attributes in your relation, but you only know the values for 2 attributes, and you want the database to fill in default values for the remaining attributes. Okay, so maybe that default value is null, or maybe it's a special value that the database has defined for those attributes. In those cases, you can insert a tuple into your relation and only specify that you are specifying these 2 attributes out of the 10 attributes. Okay, and the database will fill in values for the remaining 8 attributes based on the defaults. Okay, so maybe those defaults are null, maybe it's some other value, but the database will figure out what you want. So like I said, if we don't have values for all attributes and we want the system to fill in the missing components with a null or a default value, you simply omit the ones that you don't want to insert. Okay, so you simply omit the ones that you don't want to insert. The database will fill in default values. Another benefit of this is that your select statements can be your insert statements can be much more compact because you only need to fill in values that you know about. Okay, so you don't need to fill in all the values that you don't know about. So as an example for the likes case, I can easily do insert into likes, and let's say I wanted to insert into likes which has person and beer. I wanted to insert the fact that I know that this person needs to be added into this relation, but I don't know which beer that they like. Okay, so I can do likes and list only the person attribute, and then values and list maybe Bob. Okay, so Bob gets inserted into likes. Maybe Bob gets inserted with null as the default value for the beer. Okay, and that's totally fine. If I want to later update the beer value in this tuple to, I don't know, Bud or something, and I can do that later. But for now, Bob gets inserted with the default value for the missing attributes. In this case, the missing attribute was beer because I did not list it in the insert into component of the insert statement. Okay, so beyond explicitly listing a bunch of tuples, I have another mechanism for inserting a bunch of tuples at a time, which is even more convenient than listing out the tuples explicitly. The way to do so is to say is to have a subquery listed after the insert into relation component. So you can say insert into relation, and then you can have an entire query listed there, and that's totally fine. So for example, once again, I have, let's say, cells is a relation with bar, beer, and price. I can insert into a new relation called beers all of the beers that are listed within cells, right? So I can say insert into beers where I'm specifying the only attribute that is relevant in beers, which is name. I'm selecting all of the beers that are present in cells. So it's only this attribute within the cells relation. So this is a subquery, and this will result in many different tuples that match this subquery to be returned. All of them will be inserted into the beers relation. Any questions about this? Okay. So we talked about inserting one tuple, many tuples, omitting attributes, and insertion via subqueries. Okay, so I think we are done with insertions, but I guess I have yet another example before I wrap up. So this is an example where I want to identify or I want to create a new relation called potential buddies or pot buddies, all of Sally's potential buddies. So these are persons who frequent at least one bar that Sally also frequents. Okay, so these are people who frequent at least one bar that Sally also frequents, and I want to insert all of these individuals into this new relation called potential buddies. Okay, so the first part of this is straightforward. So I would do insert into name, and then now is where I list out the subquery, right? So what is my subquery going to look like? Again, this should be straightforward to you, armed with the tools that you learned prior to the midterm. Okay, so let me fill out a template, and then we can talk about the rest. Okay, so I'm going to start with the from clause, and I'm going to say frequents. There are many ways to do this, of course, but I'm going to try one, which is frequents f1, frequents f2. Okay, and I'm also going to do a where clause f1 dot bar is equal to f2 dot bar. And so what else might I want to add in the where clause? Sure. So f1 dot person is equal to Sally. And then anything else in the where clause before I move to the select? Yep.
Wouldn't you want to make sure that F2 that person is not Sally?
Exactly. You might want to make sure that f2 dot person is not Sally. So you might have f2 dot person not equal to f1 dot person, or another way to list this which doesn't require this greater than less than, you can equivalently say for this component you can say not of f1 dot person is equal to f2 dot person. Okay, so that's your from and where. What might you want for your select? Select f1 dot person. So there's a small way we can improve this query. What would that way be? I've left a space here for that reason. Any suggestions? Distinct? Yeah, so the issue with the query so far is that a given person might frequent multiple bars that Sally also frequents, and so this person would be repeated as many times as the number of bars that they frequent along with Sally, which is not desired. You don't want this person to be repeated multiple times, so you might want to add a distinct. Okay, so you say select distinct f1 dot person blah blah blah. All of these get added to our relation pot buddies. Okay, so this was the same query that I wrote. Let's move on to deletion. Okay, so that was insertion. Let's move on to deletion. Here I want to delete the tuples satisfying a certain condition from a given relation. Deletion again is fairly intuitive. You say delete from relation where some condition holds. Let's look at some examples. I want to delete, let's say that Sally likes Bud from the likes relation. I can do delete from likes where person is equal to Sally and beer is equal to Bud. Okay, so this is a regular old where clause like in any other select from where statement. If I want to delete everything from a relation, I can just have delete from likes, and this will delete all of the tuples within that relation. Okay, so in this case, a where clause is not needed, and it will go ahead and delete all of the tuples from that relation, but the table itself is not deleted. Okay, so the table will still stick around, so likes will still be around, but it will be an empty relation. If I wanted to delete likes as well, the fact that likes existed as a tuple, as a table, I would use the drop table statement. So I would say drop table likes semicolon, and then it would delete the table. So the first example that I conveyed was just deleting one tuple. The second example was deleting all of the tuples. What if you want to delete multiple tuples? So that's easy to do. If, for instance, I want to delete all the beers that are manufactured by Anheuser-Busch, I would just list the where clause, and it will delete all of the tuples that match my where clause. Right? So if there are multiple tuples that match my where clause, all of those tuples will be deleted. Okay, so no problems here. This is just like any where clause in a select statement. It's nothing surprising. So this is another slightly more complicated example. Let's say I want to delete from beers. Beers has name and manufacturer. All the beers for which there's another beer by the same manufacturer. So here I would use a subquery. I would say delete from beers B, where name in select b1.name from beers B1, beers B2, where b1.manufacturer is equal to b2.manufacturer, and b1.name is not equal to b2.name. So what is going on here is I am selecting the beer, so b1.name, or rather let me go step by step. So I'm starting with a join of b1 and b2, and I want to match up the beers that have the same manufacturer but have two different names. Okay, so I've matched up all of those beers, and then I've gone and selected those beers. Okay, so I've selected b1.name such that there's another beer that is manufactured by the same manufacturer. And then once I've selected all of those tuples, that is the result of the subquery. These are all beers with the same manufacturer and a different, and there's another beer also made by the same manufacturer. Then I go ahead and delete from beers. Okay, so I go ahead and delete from beers such that so actually I don't really need any of this, but so I could use a subquery here, but hang on. Let me just make sure I'm not doing anything stupid. Okay, so let's try to work through this once again. So I noticed a beer B here, which I don't think is necessary, but let me go through that once again. Okay, so let's start with the subquery. So the subquery is selecting all of the beers such that there is another beer by the same manufacturer which has a different name, correct? So good so far? Okay, so that's fine. And I want to delete from beers all of those beers such that they satisfy this condition. Okay, so I don't need this B. So I don't really, I think I may have had a previous query here or try to write a previous query which involved B within the subquery. I don't need that, at least in this case. If I wanted to use that, that's totally fine. But in this case, I don't need to use the tuple variable B. Okay, can you guys see that? This will make sense. I hope it's not confusing. I don't need to use B because I don't need to refer to B within the subquery. But if I did, I can do that if that was the way I wanted to write the query. I think there's another way to write this query where you list this tuple variable B and then use that within the subquery. I encourage you to go try it out. It should be fairly straightforward. This is just like a regular old subquery. But for now, because that's not the focus of what I'm going after, let's get rid of this tuple variable B and then focus on the semantics of delete. Okay? Any questions about this? Or if something is truly confusing, I can try to get into it. Okay. So let's talk about what happens when deletion occurs. In this case, I am deleting all of the tuples that such that there's another beer by the same manufacturer. This can lead to unintended consequences depending on what rule I adopt for deletion. So, let's say I have this relation to start off, just two tuples, one corresponding to Bud and one corresponding to Bud Light, and I want to check, I want to delete once again all the tuples where there is another beer by the same manufacturer. As it turns out, there are three different final results that you can end up with depending on how you execute this query. Okay, and once again, I don't need this tuple variable, so I'm going to skip that. So there are three different outputs that you can end up with depending on how you execute this query. Any guesses on how you might end up with one of this, this, or this? Just walk through what is going on, right? So this relation, the way we are going about doing the deletion is we are checking if that beer is something that is also made by another, is one of those beers that is also made by another, or is one of those beers where the manufacturer makes multiple beers, right? So based on that, can you tell me how you would end up with one of these three final results? Pick any one and tell me how you would end up with that. Yep.
So you might check for bud, and then you might check for life. Do those checking twice, then you might delete the other one.
Correct. Right. So let's say I am working on this relation in two different ways. If I start with bud, so that's the first tuple that I'm processing, and I want to check whether bud is one of those beers that is such that the manufacturer, Bush, has multiple beers that are manufactured by that manufacturer, right? So if I operate on this tuple first, I will certainly find that here this is, hang on. Okay, so this is, it should be, these should be name. Sorry about that. Okay, so where bud in the result of this subquery, I'm going to look at all of the beers that have multiple beers that are made by the same manufacturer. Bud is going to match that criteria, so I might end up deleting this tuple first. Okay, so let's say I go ahead and delete that tuple first. Now I'm left with one tuple. That tuple, if you try to evaluate this subquery once again, you might end up realizing that there is no other beer that's made by the same manufacturer. So in that case, if you went ahead and deleted this tuple first, when you're evaluating the second tuple, you won't be able to delete that second tuple, and therefore you will end up in this eventual result. Okay, so you will end up in this eventual result. Another way to execute this query would be you start with this tuple first, the Bud Light, check if the manufacturer for Bud Light sells multiple beers. Yes, it does, and so you would go ahead and delete this tuple. If you deleted that tuple, you will end up in this regime where you have Bud as the final result. Okay, so if you are sequentially processing and deleting tuples, you will end up with one of these two results. Another way of doing this is, let's say I went ahead and evaluated this subquery first, right? So I went ahead and evaluated this subquery first. Now that subquery has both Bud and Bud Light. If that subquery has both Bud and Bud Light, and I'm not changing the results of that subquery, then as I'm processing these tuples, Bud and Bud Light, I will find that both Bud and Bud Light belong to the results of the subquery, therefore both should be deleted, therefore I will end up in this regime. Okay, so overall, hopefully it's, I managed to convey that this is confusing, right? It's not entirely clear where you would end up, depending on what you end up doing. So one option is you start one tuple at a time. For each tuple, you evaluate the subquery, and then you decide to whether to delete that tuple or not. That will lead you to one of these two outcomes based on which tuple you evaluate first. The other strategy, which is to evaluate the subquery first, and then you go ahead and evaluate the deletion condition, would basically end up having you delete both of the tuples. Correct? Any questions about this? Okay, so what do we do in this case? What does the system actually do in this case? The way the system works is instead of having this confusing semantics, it operates in two different phases. The first phase is to mark out all of the tuples that are going to be deleted and then actually delete them. So in the first phase, it will just mark out all of the tuples that are going to be deleted, doesn't actually delete them, and then it will go ahead and delete them in the second phase. Okay, so if it does it in this manner, which of these three options do you think we'll end up with? Last one, right? Because you will mark both Bud and Bud Light to be deleted, and then in the second phase you will delete both of them, right? So that's nice in some sense because it's a deterministic outcome. No matter what order you process stuff, it doesn't matter because the first phase is always going to mark out all of the tuples that are relevant for the query. The second phase is going to go ahead and delete them. Okay, so that's the semantics that that database systems follow. Once again, it's two phases. The first phase marks out all of the tuples. The second phase goes ahead and deletes them. And this makes the deletion process deterministic as opposed to random, depending on which order of tuples you decide to process. Okay? All right. Then to updates. Okay, once again, updates is, the syntax is fairly intuitive. You say update relation, set some attribute to be something, where some conditions on tuples, and then semicolon. So if I want to, for instance, change Fred's phone number to 5551212, I can do that. I can say update person, set phone number is equal to blah, where name is equal to Fred, semicolon. Okay. I can also reuse the attribute within the assignment statement. So I can say update person, set phone is equal to 217. This is a symbol for adding two strings, so 217 plus phone, if you will, where name is equal to Fred. That's totally fine. I can also do arithmetic. So here I'm updating the cells table, doubling the price of every beer in this case, where the price is less than 3.0. In this case, once again, I have an issue just like in the deletion case, right? So why do you think that is? And how would we solve it? Yep.
It depends if we do the price comparison before or after the multiplication.
So what could be one, or what are some options that could happen, right? If you do it willy-nilly without worrying about it.
We could always evaluate whatever's in set first, then do whatever's in where.
You could always evaluate whatever is in set first and then evaluate whatever is in where. So you still do have to evaluate the where first to figure out which tuples qualify. So you would, so okay, so the right way to do this, let me talk about the right way to do this, and then I'll talk about what are the issues. The right way to do this would be to figure out which of the tuples need to be updated, right? So that's step one. And then step two would be to update them. Okay, so that's first you, like the deletion case, you mark out all of the tuples that need to be updated. Step two, you update them. But if you don't do it in this way, what could happen? Yes?
If you apply the set condition and then still check through them again, they still might not satisfy the where.
Correct, right? So if you don't record which tuples you've updated, and you go through the same set of tuples again, you may end up processing the same tuple multiple times, which may not be what you intended, right? So let's say your price was 0.5, okay, and you have only one tuple in your database. You have price equal to 0.5. It matched the price is less than 3 condition. Okay, so you went ahead and doubled that. So now it's price is equal to 1. You go through the set of tuples again, and now price is 1. Again, it matches the where condition. I can double it again, and I can keep doing this. Because if I don't keep track of which tuples I've processed and which tuples I have not processed, because now that I've changed the tuple, it's a new tuple effectively, right? So if I'm not being careful, I might end up updating the same tuple multiple times. And this, in the past, there have been, when people were not as careful about database query semantics, there were cases where, let's say you had this issue or rather, there were cases where you would end up updating a value, and this value would just keep getting updated up until it hit infinity. Okay, so up until it hit the maximum value that could be held in your attribute. Okay, and this could be, for instance, a case where price instead of less than 3, here it's at least deterministic. It'll stop once the price hits 3, if you instead had price is greater than 3, then this could keep doubling all the way up to an arbitrarily large value, right? So it could just keep doubling if you're not being very careful. So once again, the same deletion approach of marking the tuples and then updating next is the right approach because it will touch each tuple exactly once. Okay, so that's great, right? Okay. Any questions about this? Okay. All right. So so we talked about like overall SQL querying based on basic queries, set-based queries, subqueries, aggregates and grouping. We talked about modifications. Let's talk about views next. Okay. So views are essentially virtual tables. These are named query results. Okay, so that's another way of thinking about views. The way you declare a view is to say create view name as some subquery. Okay, you say that the results of this query, I'm giving it a name, and I'm going to refer to that using that name. So this is, in a sense, it's a relation that is defined in terms of the contents of the other tables and other views. So I could certainly refer to a view within a regular SQL statement, just like any other relation. So basically, a view is a virtual table. It's a named query result. I can treat it like a regular table. Views are not stored in the database, but they can be queried as if they are stored in the database. So you can pretend like these view tables are actually stored within the database. But we'll talk about an exception where you can actually force it to be stored. And in contrast, a relation whose value is actually stored in the database, so these are the relations that we've been talking about so far, these are what we call as base tables. Okay, so these are the vanilla relations that we've been talking about so far. These are called base tables. Views, on the other hand, are virtual tables. These are named query results. Okay, so virtual tables are named query results. Okay, so here's an example of a view. Here I want to find all of the person beer pairs such that the person frequents at least one bar that serves the specific beer using relations frequents and sells. So the query is straightforward. I select person and beer from frequents and sells, where frequents.bar is equal to sells.bar. That is my subquery, if you will, which is containing the person beer pairs such that the person frequents at least one bar that sells a beer. Then I am defining that subquery as a new view which is called can drink, and can drink has two attributes, person and beer, because these are the results of your select clause. Right? So these are two tuples that are these are two attributes that are listed in your select clause. These are the two attributes that are going to be part of this view or this virtual table. And then once I have defined this virtual table, once I have defined can drink in this fashion, can drink is now, I can treat that as a regular old relation. I can operate on it the way I want. I can use it in queries. I can do whatever I want with it. There are some complications though. I'll get to that in a little bit. So why would I want to define these views? There are multiple reasons. So the first reason is convenience. If I repeatedly use a subquery, then I might want to give it a name, right? So that I don't need to list the same subquery every time I want to use it. The second reason is for access control. So let's say I want to allow you to access a certain portion of the table corresponding to grades, and I only want you to be able to access one of your rows, not the other students' rows. I can define a view for you and then have you be only allowed to access that view result. So that view might be select star from grades table where net ID is equal to something. And that can be a view that only you are given permission to access, or rather you are only given permission to access that and nothing else. So that's access control. The third reason is for efficiency. This is less relevant when the table is virtual. It is more relevant when you actually decided to store the results of that table on disk. You can choose to do that. That's called a materialized view. We'll come to that later. So accessing a view, like I said, is just like accessing a regular old relation. You can query a view as if it was a base table. You can say select beer from canned drink where person is equal to Sally. Remember, canned drink was a view that we defined a few slides ago. Now, what happens when a view is used within a query? The way the database system sort of interprets a query that uses a view is that it interprets other parts of the query first. It creates the relational algebra expression corresponding to the other parts of the query. And then finally, for that view expression, it replaces that view expression with the relational algebra meaning for that view. And then you have a giant relational algebra expression, and then that's what is evaluated by the database system. So the queries that define any views that are used by the query that you're defining or the query that you're issuing are also replaced by the algebraic equivalence and are spliced into the expression tree for the query. So here's an example. So the query that I issued earlier was project beer. So this is pi, this is sigma. So project the beer, so that you only want to return the beer attribute where person is equal to Sally, and you're operating on this view, can drink. So internally the database system would replace this can drink invocation with the subtree corresponding to the relational algebra meaning of that view, which is project person comma beer on the result of the natural join of frequency and cells. Okay, so that's what this view would get expanded out to. So the last part is how do you deal with updation of views. This is where things get a little complicated. So you can update a view, but this updation needs to be a little carefully done. It needs to make sense as a modification of the underlying base table. What do I mean by that? Right, so let's say I have a view which is Joe Mo bar cells, okay, and this is defined to be the set of beers and prices from cells where bar is equal to Joe bar or bar is equal to Mo bar. Okay, so these are all of the beers and prices for beers that are sold at Joe bar or Mo bar. Okay, now let's say I go ahead and insert into this view. Okay, so this view was Joe Mo bar cells. I insert into this view values Bud Special and 3.5. So that's a new beer and that's a new price. I can take this and then I can turn it into an insertion statement for the base table, which is cells. Unfortunately, I can't tell whether this tuple, which was inserted into Joe Mo bar cells, is for Joe bar or Mo bar, because that's not specified in the insertion statement, right? So unfortunately, the Joe Mo bar cells view does not have that attribute value. Because it doesn't have that attribute value, I can't associate this tuple that gets inserted. So you can think of this in the following way. So you have a relation R, and then you have a relation or a virtual table V, right? I've gone and inserted a tuple into V, T. Now that tuple, I may not be able to, I need to push it back into the relation R, but in pushing it back to the relation R, I may not be able to fill up all of the values for all of the attributes, because in some cases, like in this case, there is ambiguity between whether it's Joe bar or Mo bar, right? So even if I insert it into the view, I don't know how to insert it back into the base table R. So in this case, I would insert it with value null corresponding to the bar attribute, because I don't know whether it's Joe bar or Mo bar. Now, there's something really funky that happens. So I've gone and inserted something into the view, and this tuple has been pushed all the way to the base table. So that's good. But let's answer the following question. So is this new table in cells? Yes, right, it's been pushed down to the base table. Once I've inserted into cells, it's obviously part of cells. But is it in the view Joe Mo bar cells? No. Right, so the issue is that even though you've taken this tuple, you pushed it all the way back into R, when I try to apply this, query and I try to recreate the view, when I try to select the tuples that should belong to V, that tuple will not qualify anymore because it has null as opposed to either Joe bar or Mo bar. Right? Only if it is Joe bar or Mo bar would that tuple qualify to be part of the view. So even though I've taken this tuple, I push it all the way to the base relation, when I'm applying a selection to try to find the view again, that tuple is missing. Right? So it's weird because I've explicitly said insert this tuple into the view, but that tuple doesn't get inserted. Right? It gets inserted into the base table and all, so that's fine, but it doesn't get inserted into the view. And that's because of this issue where the query did not clearly identify a value for every one of its attributes. It only had only selected some of the attributes corresponding to beer and price. It didn't select a single value for bar. Okay? So if instead, okay, so let's switch to the next example. So if instead the view was bar, beer and price, so Joe Mo bar cells is bar, beer and price from cells where bar is equal to Joe bar or bar is equal to Mo bar, and I make an insertion Joe bar, Bud special and 3.5. Remember that here I need to identify the bar that I'm adding. This is easy to translate into an insertion on cells. It's the same tuple that gets added to cells. I don't need to add any nulls, no worries on that front. Now a query on the view Joe Mo bar cells will return the Bud special tuple as well. But so this is fine, so this is good behavior, but we can insert into Joe Mo bar cells a different bar. Let's say instead of Joe bar or Mo bar, I can have a flow bar, and that tuple will get pushed into the cells relation, but it will not be part of the view. Does it make sense? So if I follow the same rule of taking that same tuple and inserting it into the cells relation, it will become part of the cells relation, but it won't be part of the view. So just like in the previous case, I went and inserted something into the view, it became part of the base relation with a null value, but it's not part of the view. Here, if I insert something with a different value for the bar attribute, it'll go and be part of the base table, it'll get inserted into the base table, but won't be part of the view. So once again, you have some unexpected behavior depending on which query you use, depending on which select attributes, which attributes you've listed in the select clause of your view. Okay, so this is somewhat confusing. Okay, so so this issue is something that's referred to as the view modification problem. This is something that a lot of researchers have spent considerable time thinking about, figuring out how to manage and manipulate. Okay, so there are some rules that people have come up with over time. These are rules that allow you to update the views. Loosely speaking, these rules they satisfy these conditions. The first is that the view must have been defined using selection on one relation. Okay, so not multiple relations. If it's a join, then things are going to get very confusing, so you don't want to use a join. The where clause must not involve R as within a correlated subquery. If there's a correlated subquery, once again, it becomes very confusing to associate a tuple that's inserted into the view to a tuple that's inserted into the base table. The select list must include every attribute for which we cannot fill in null as a default value. remember that in the example that we saw 2 slides ago, here we were able to fill in null as a default value for bar, so we were in fine shape. But if we couldn't fill in null as a default value, then there's no way we can insert a tuple into the view as a corresponding insert into the base table. And of course, like we saw earlier, even when an update is allowed, it may not work as intuitively as you would expect, right? So sometimes an update into the view, or you add a tuple into the view, that tuple may not even show up as part of the view, right, depending on what you add. Okay, so why don't I stop here? I will cover this last bit once again, and then move on to the final topic within SQL.